We're on lesson 3 of chapter 7, which is populations and samples. First, we're going to analyze sampling methods. Then we're going to identify potentially biased samples. Then we're going to verify claims based on statistical data. First, let's define our words here. Population defines a whole group of people. It doesn't need to be all the people in the world, but it's a specific group of people that you want to target and find out more information about. A sample is often used because getting information from all the population, well, that would be a lot of work. That's a lot of people to ask. And usually populations are much larger than this group right here. So you can ask a smaller group of people in your sample here, and then you'll get a pretty good idea of what the whole population thinks. We're going to learn about 3 different types of samples, some good and some bad. The first sample we're going to come across today is called a convenience sample. If you want to think of another word, you could also think of lazy sample. So for example, I wanted to ask this population here, but I really didn't want to go too far to find the people to ask, so I just took this group right here and decided to ask them my question. This is a convenience sample, meaning I just took the people that were closest to me or who were easiest to ask. And this could lead to some very bad data. For example, like in this population, people who are close together, they might share the same ideas, whereas people over here might share different ideas. Based on your position or where you are, you might have some commonalities with those close by you. So a convenience sample is often a bad sample because it doesn't reflect the entire population, and that's what you want it to do. A biased sample might even be worse. You can even get deceitful here. Let's say I wanted to prove that blue is everyone's favorite color. Well, I know that this person likes blue, this person likes blue, this person, this person. So I'm just going to ask these people what their favorite color is. Maybe I'll ask a couple other people who like green and red, just to balance it out a little bit. So since I asked all these people, my winning answer was blue. But that's because I asked specific people. I was biased. I really wanted blue to win, so that's why this is not going to be a good sample at all. Our last sample is called the random sample, and this could also be called a blind sample, meaning that you truly ask people randomly. You don't pick and choose. You don't choose it because it's convenient or they have the right answer. So it's just a random selection of people, no matter what they like. And in that case, this is a true sampling of the population. It might not be 100% correct, but if you ask enough people in the population, you can get a pretty good idea of how the population feels about something. So that's why in this lesson today, we're really going to be preferring the random sampling. So now let's determine which sampling method will better represent the entire population and then justify our answer. So they're at a football game and they're going to determine student attendance. Here's the sampling method and here's the results. It says Arnie surveys 80 students by randomly choosing names from a school directory. And out of that, 62% attended the football games. Vic, on the other hand, surveyed 28 students that were sitting near him during lunch. To me, this looks like a convenience sample. They were closest to him. It was easy to ask all these people by him. So this wouldn't be the best sample. And you'll notice that more of these people attended the football games. Maybe Vic is a football player, so he sits all by all the football players. And that's going to skew the data. It's going to be wrong then. This is probably not 81% of the people in the school are attending that football game. Arnie, on the other hand, randomly chose names from the school directory, meaning that every single student had a same chance of being selected. And he chose more students as well, which is also a very good sign. A larger sample is usually going to be more accurate. So this 62% is probably more correct. So we're going to say Arnie because Vic used a convenience sample and asked fewer people. Now we need to determine whether each sample may be biased and then explain our answer. It says the first 50 people exiting a movie are surveyed to find out what type of movie people in town like to see. At first you might not think this is bad. Oh, moviegoers, they know what they like. But think about this. What if you wanted everyone to say that Batman was their favorite movie? Well, in this case, this person could go to the end of the Batman movie and ask everyone leaving the Batman movie what type of movie they like to see. Whereas most of those people are going to say Batman because they just saw Batman. So that would make it biased. A not biased answer would be kind of using the town directory or maybe asking people at many times throughout the day during the movie theater. So we're going to say biased because the movie watchers all saw the same movie. Here it says the librarian randomly chooses 100 books from the library's database to calculate the average length of a library book. Now, this is the key word right here, that randomly. That means that she didn't choose books that she wanted to prove. So, meaning even if she wanted all the books to be very long, she randomly chose the books. So that means that it's going to be a very true example. So we'll say not biased because the books were randomly chosen. Here we're going to verify a claim based on statistical data. It says a biologist estimates that more than 700 of the 4,500 elk at a wildlife preserve are infected with a parasite. A random sample, which is good, he chose a random sample, of 50 elk show that 8 of them are infected. So determine whether the biologist's estimate is likely to be accurate. So the biologist thinks that 700 out of 4,500 are infected. He took a sample of that population, a sample of 50 elk, and he found out that 8 of them are infected. So what we could do here, if we see the sample of 50 and then 8 of them were infected, if we did the proportion to find out the whole population, would that turn into 700? Let's find out. So the whole population is 4,500 elk. The sample was 50. So the infected of the sample was 8. So what is the infected number of elk in the whole population? So we can do this like our equation here. We have 50x, and that equals 8 times 4,500. 8 times 4,500 is 36,000. So we have 50x equals 36,000. Divide both sides by 50. 36,000 divided by 50 is going to be 720. So the number infected elk is going to be 720. So his estimate was that more than 700 of the elk were infected. Using the random sample, he had 8 out of 50, which is equivalent to 720. So it is a very reasonable estimate that more than 700 would be infected. So in that case, we would say it's likely accurate. So in that case, we would say it is likely accurate.